My name is Alon Rabinovich. I'm a PhD student at Rutgers University working with Saki Raouf in the Environmental Geochemistry Lab. Our SARE project is to recover nutrient and irrigation water from livestock wastewater. We have a farm over there. It's about 100 milking cow, and they have a 750,000 gallon lagoon. And we treat it first with a Strovate Reactor. It's a precipitation reactor that salt out nutrient out of the wastewater and precipitate it as a solid fertilizer. What we get out of the reactor is something like this. If you can zoom up in the camera, is a solid. The solid is a mixture of calcite and struvite. Struvite is magnesium ammonium phosphate, and you can use it as a slow release fertilizer for crop field. From the lagoon behind us, effluent would be pumped into a barrel that does a pre-filtration with rocks to prevent solid from clogging the system, and from there a peristatic pump would pump the effluent into the reactor. The reactor has two chambers. One is a mixer reactor for precipitation, and the other one is a plug flow reactor for solid collection. Now, the agitation with an overhead mixer prevents solid from settling and promote the reaction. And we have an air pump that flow air into the reactor. We flow air to the reactor to raise the pH. The phosphate would precipitate as struvite at pH of about 9. So if we start at a pH of 7.9 in the barrel, aeration in the mixer, in the mixing reaction, would get the pH to 8.5. An additional application of sodium hydroxide would get the pH to about pH 9. At this pH, struvite would precipitate freely in the effluent, and then we can use the plug flow reactor, which is basically a cone that expands, and as the cone expands, the flow speed goes slower, and solid would be returned inside the plug flow cone, while the effluent leave the reactor and go to additional treatment. So we can harvest the solid out of the reactor and collect it for research or to use it as a fertilizer. After we treat the effluent for phosphate removal, effluent goes for constructed wetland treatment to remove biological oxygen demand, or BOD, and suspended solid, TSS, total suspended solid. So this treatment, after we harvest as much of the nutrient as we can, we want to treat the water so we can either clean them up, discharge them, or pipe them into an irrigation system. So we have three kinds of constructed wetland treatment. The first one is a vegetated submerged flow, where you have a bed full of rock matrix with an overhead plant for soil stability, and you have a second bed, which is a free water surface bed with a margin plant, and you have a third bed that is free water surface with submerged plant. So we're trying to do an alternative method where you can substitute manure spraying with a treatment that remove nutrient and still meet the requirement for BOD and TSS, so we can limit the problem of eutrophication buildup in waterways that is a growing concern in the northeast region. So what we take from this as a preliminary result is that if we extrapolate those pool systems, we might end up meeting the requirement goal for treatment for TSS and biochemical oxygen demand. So this work was all about phosphate recovery, and we were recovering about 60% of the phosphate and seeing how this phosphate recovery performed together with the wetland treatment to see if it's a viable approach. So you would say that we would have an estimated biochemical oxygen demand of about 250 at this point, and about 2,500 milligram per liter at the lagoon.